Let's go to guided practice 4. Newton's law of cooling states that the rate change of temperature of an object is proportional to the difference between its own temperature and the surrounding temperature Ts. Suppose you have just poured a cup of coffee with a temperature of 75 degrees and it takes 3 minutes to drop to 50 degrees. The room temperature is 24 degrees. For A, write a differential equation using the initial conditions given. We know that Ts equals 24 degrees. Therefore, according to the given information, the rate change of temperature is proportional to the difference between its own temperature and the surrounding temperature, which means dt by dt proportional to the difference, so T minus 24. Then we can write down d capital T by dt equals, we will use a constant number k times T minus 24. Since the temperature is dropping, which means this will be negative before k, then k greater than 0. The initial condition given, when T equal to 0, then the capital T equals 75 degrees. When T equals 3, capital T equals 50 degrees. This will be the differential equation with the given conditions. We solve the differential equation. Then we try to solve this differential equation. Both sides you multiply by dt, then divided by t minus 24. You will get the d capital T over t minus 24 equals negative k dt. Then you will do integral both sides. You will get the natural log of t minus 24 equals negative k times t plus c. Sides make e as the base. Do the power. You will get t minus 24 equals e negative k times t plus c. Make a equals e to the 6th power, so that you will get t minus 24 equals a times e to the negative k times t. So you add 24 both sides, you will get the t equals 24 plus a times e to the negative k times t. Substitute the first initial condition. You will get 75 equals 24 plus a times e to the 0 power. Then you will get the a equals 51. For second condition, t equals 3, capital T equals 50, you will get 50 equals 24 plus 51, because we got the a equals 51, e to the negative k times 3. To solve for k this time, so you subtract 24 both sides, you will get the 26 equals 51 times e to the negative k times 3. So we divide by 51, you will get the 26 over 51 equals e to the negative 3 k's power equals 0.225. Therefore, the solution will be t equals 24 plus 51 times e to the negative 0.225 t. To say, explain from the equation why temperature will never go below 24 degrees. Because for exponential function e to the negative 0.225 t is always greater than 0. Therefore, t will be greater than 24, because for this side is always greater than 0. Go to guided practice 5. A cylindrical tank of radius r is filled with water. A hole of area a meter squared is made in the bottom of a tank. The velocity of water through the hole is v meter per second. The volume of water in the tank at time t seconds after the hole is made is v meter cubed. Let h be the height of water remaining in the tank after t seconds. Given that v equals square root of 2gh, show that dv by dt equals negative a square root 2gh. First of all, let's figure out the volume of the remaining water in the tank first. So this v equals v0 minus this area times velocity times t. This v0 will be the volume of the tank, because the tank is filled with water at the very beginning. Therefore, this v0 will be the constant minus a times square root 2gh times t. Then we will do the derivative. dv by dt equals v0 will be 0, because this is the original volume of the tank is constant, minus a times square root 2gh. We organize, you will get the dv by dt equals negative a times square root 2gh. Let's go to b. Hence, show that dv by dt equals negative k square root of v. Here k is a constant. Suppose the height of remaining water in the tank is h. Therefore, we can get the volume equals pi r squared times this h. We solve for h. You can get v over pi r squared. Then use the conclusion we got for a. dv by dt equals negative a times square root 2g times. We substitute this h equals v over pi r squared into this function. You will get v over pi r squared. We organize, you will get the negative a times square root 2g over pi r squared times the square root of v. Since this a, g, pi, r squared are constant, therefore we can make k equals a times the square root 2g over pi r squared. This k is a constant too. Therefore, we can rewrite this differential equation. dv by dt equals negative k times the square root of v. For second one, state the value of k in terms of a, r, and g. We already state here. Go to C. The volume of the cylinder when full is V0. Find how long it will take the cylinder to empty in terms of K and V0. We need to solve this differential equation. You will get the dV equals multiplied by dt both sides, negative K square root of V dt. Then we divide by square root of v both sides. You will get the dv over square root of v equals negative k dt. Then we will do integral both sides. You will get here that v to the negative 1/2 power. So when you do the integral, you will get negative 1/2 plus 1, you will get the 1/2. Here's v 1/2. So you get the 2 square root of v equals negative k times t plus c. According to the given information, t equals 0. This v equals v0. Therefore, you will get 2v0 equals c. Therefore, you will get 2 square root of v equals negative k times t plus 2 square root of v0. We want to figure out this t when v equals 0. Therefore, you will get negative k times t plus 2 square root of v0 equal to 0. We solve for t. The t equals, cross this equal sign, you will get the negative 2 square root of v0. Then you divide it by negative k. Organize, you will get the 2 square root v0 over k. This will be t. So after these seconds, the cylinder will be empty.